Welcome back, Linux enthusiast. This is the 19th episode of our Linux learning series. If you have missed any of our previous episodes, you can check out the playlist here. In this video, we'll be talking about arguments and variables in the shell scripting. If you're looking to upskill in Linux and get globally recognized certificates, you can check out our DevOps course. The link is given below in the description box. Alright, so now let's start the video. Alright, so we have reviewed the various loops available in this shell scripting, and we have also seen what is this shell and what is tiny typewriter, where the application programs gets executed. So far we have listed down the basic concepts of shell scripting and various loops. For example, if loop, while loop, if else loop, if elif loop, for loop, until loop. Then there are statements, for example, continue to skip a particular statement, or break to break the loop at whatever the condition, until loop, until the condition is matching, run the loop, after that breaks the loop. So there are so and so forth, operators also we have discussed. And in this session, we'll be talking about mainly the arguments and the variables that we have been using in the shell scriptings. So let's talk about those variables and arguments that we pass on in the shell scripting. So you must have seen some random values generators and stuff like that. So for example, there are some predefined variables which are present and belongs to the shell. For example, pwd. So if you want to print the output of present working directory, pwd command can also do the same stuff, but there is a variable which is available to the local and as well as the global variable, and once you execute, try to print the value of that variable. So there are some predefined variables. For example, pwd is one of that. So this dollar means you want the value of this pwd variable, and what I want to do is I want to echo it, which means I want to print the value of pwd. So this is kind of printing that value. Similarly, there is some random variable which is also there, which basically prints the random variable every time. You want a random value generators, so it prints that value it for you, but it has a limit, like from 0 to 32,767. It basically prints that value from. So it's kind of a random generator, you can see. Then there is something called path. So path is basically, I think we have seen this in the file hierarchy systems when we were talking about various paths in Linux systems. So path is nothing but these are the locations. If you keep any command in this location, the command will behave like, like any executable file can be behave like a command. We will see that shortly. How do you create your own command? Basically, you just have to put that executable file with whatever the name you want to create as a name of a command, and then you can put it into any of these locations. It will be treated as a command for you. So that is a path variable where you basically export the paths for the executable files. Then we have terminal. To print the terminal, what terms are you using? So this is nothing but related to some terminal. So it is using 256 color xterm based application as a term. Then if you want to print the UID of the user that you have currently logged in, so star agile UID is 1005. You can confirm this by etc passwd. This we discussed while creating the passwords, if you remember in our previous chapters. So star agile, this is the UID and this is the GID. So UID of star agile user is 1005 is what you are getting from the UID variable, which is also a global variable, but that thing depends on with the current user that you have logged in, it will tell you the UID for that user. If I switch to, let's say, Himanshu1, in that case it will print the UID for Himanshu1 user rather than printing the UID for star agile user. So you see the difference here. So that's how the UID variable is being used. And then there are some language variable also, which you can use to see which language it is currently using my keyboard. So it's using US English UTF-8 encoding. Basically it is using that encoding methods. You can change that settings as well, and then you can manipulate it based on the customizations requirement for your Linux systems. You can do it. Then there is one more, we have important one is a home. So this is nothing but a home directory what you see for any user. So for example, StarAgile, the home directory for StarAgile is /home/StarAgile. If I log into, let's say, Himanshu1, so the home directory for Himanshu user would be /home/Himanshu. So we will see that in a bit. Okay, so this is how you see the home directory. It prints for any user whatever is logged into your systems. Now let's talk about some variables. How do you define the variable? So for example, in Linux shell scriptings, variables can be defined like let's say var, var1. It can have A to Z, okay, or capital A to Z, or 0 to 9, any numbers you can have, or underscores also it can support to create a variables. But things to note, for example, let's try to create some variables and we will analyze how does it work. So for example, I can create any variable with starting with underscores. Let's say var1, I'm passing the value Himanshu, okay, and I want to print the value of that variable, so I can use var1. So it will print me the value of underscore var1 variable. Okay, you can create a variable with capital letter also, let's say var, which is, let's say, test, and then echo $var. It will print the value for test. So it can start with capital letter, it can start with small letter like this, and both are different. If I say echo $var, as we spoke that Linux is a case sensitive, so it takes variable also as a case sensitive, where it is in case of lowercase, it is printing and accepting the value for whatever the value you have provided for the lowercase, and for uppercase it is taking the value whatever you have provided separately for the uppercase. And you can also create a variable with a numeric digit, for example 1 variable, and say uu. Uu is a command, so command okay, means it is not accepting that for you. Okay, so you cannot create this is like invalid examples of creating any variables. You can create like let's say var underscore 1, so that also works here, and you can just print the value of var underscore 1, it will print yy for you. So these are like common ways of creating the variable. Just two things to note, that it can accept small a to small z, then capital A to capital Z, then numeric 0 to 9. Now there are some ways, or I would say there are some variable definitions which are not valid in terms of Linux. For example, you cannot create any variable with numbers, what we were trying to do before. So when you try to create any variable with numbers, it says command not found. So basically it tries to think that are you executing any command, but there is no such command called one var -text. So it treats this as a command rather than a variable. So this is unacceptable. Linux does not accept it. Or you are using hyphen, let's say var -1, that time also it is treating this as a command, so it's saying command not found. So this is also unexpected behavior in terms of setting up the variable. You cannot use hyphen, you can anytime use underscores. Underscores works but not hyphen. Okay, now after that you cannot use any special characters. Let's say I want to use exclamation, that time also it says this exclamation is not identified. So exclamation mark is also invalid pattern of providing the variable information. So this is also not a valid one. Also you cannot like with hyphen, starting with hyphen also does not accept, in between hyphen also it does not accept. So hyphens are not acceptable. Anything other than underscore as a special character is not acceptable. Then it cannot start with a number, that is also not acceptable. So these are the a variety of acceptable options, or I would say variables which are not allowed in order to create it. Now what you can do is like you can access the variables. Uh, so these are the variables that we have defined, and you can access it anytime by using $sign. For example, let's say var1, you can, there is no variable, then it's okay. One var, you can print the value of that variable, whatever the variable that you are going to create. So these are the variables called scalar variables, which means that it stores the value once. And if you, let's say I have a variable var1 and I say value Himanshu, and if I print the value, it will print the value Himanshu to me. Why I say scalar? Because next time if I change the value of var1, this time it will basically change the value. So it replaces the value. It's like, you can think like a volatile memory, right? It just replaces the value quickly. It's nothing permanent until you create any shell level variable or any global variable. So these are the local variables, scalar variables, which means you can change it anytime, in the same session also. These variables cannot be applicable on any other session. So for example, currently you see we are getting a value of var1. What if I create a new shell session? So in that case, if I try to do echo, it will not recognize this variable, because this variable is not was not created on this shell. It might be created on some other shell. That's why those are the variables are local variables, not being used or not being can be usable for any other shell. So if I go back to my previous shell by exiting the connection, so as soon as I exit the session, I am able to do a var1. So it is giving me the response back. That's what the beauty of creation of the scalar variables, where you can just manipulate the values whatever you would want to do n number of times here on the shell session. So those are the variables. And you can similarly like create script for variables to access it. For example, let's create a script variable .sh, example like this. Okay, we'll say shebang header. See, shebang header is not required. It's just that a denotion of showing that we are going to write a shell script here. So that's why. Otherwise, it's all fine. So I have a variable which I say Himanshu. Okay, now I'll say echo. Here is the variable. Okay, so now variable.sh, so it is printing me the value of a variable whatever you have assigned. We can make some modifications here. Instead of doing this way, we can see this echo. Okay, then it is reading variable and then it is printing again. Please enter the variable value. Let's say I enter star agile. Okay, after that it says okay, here is the variable value which is star agile. So you can use the same concepts of what we have been seeing in the previous chapters while reading the arguments from the command line, and then you can use this concept of variables, and then you can provide the variable, and then you can get the output of it. Now the same script, if I execute from another session, this will work. You will get the output of here is the variable value star agile. Reason being, in the new session also, you will when you execute this script, since this script has the content where it is always trying to get the variable value on the fly, and that's how it is able to respond back. See, what I'm trying to say is, let's say if you execute the same script, it prints the value whatever I say, because it is asking every time the value from you. So doesn't matter which session you are on, since the at wherever session you have currently logged in, on which shell, you can just pass on this value and then you can get the output of the variable. Okay, that is this scalar value variable use cases. After that, we will see read-only variables. So read-only variables are basically the variables which can be set as a read-only variables. So so there is a syntax to set a variable to a read-only. For example, like let's say read-only. Okay, so let's create a script. Okay, now read variable. You can, I think you can do like this also, and then echo. Dollar where. We have not read it, that's why. Read only variable, then we can have echo. Okay, so the value is, so this variable is currently the read only. What I say when I say read only, so for example like this, if you assign any variable, okay, and you make this variable read only. Okay, now if I try to make any changes further to this variable, so after that you get a complaint from the shell, a message saying that this variable is currently in the read only variable. Once the variable is marked as a read only variable, you cannot change it, like you cannot update the value of any read only variable if you are into this current session. So until you change the session or you relog in with same user or another user and then go to the shell and then create a variable, this will be like set as a read only. So this will not be used for any other values, it cannot take. So that's the use case of read only variable. So it is basically being used, you can think like a constant, the value is always read only, so which means it cannot be overwritten, it cannot be changed, you can just read the value whenever it's required. So think like an example where there is a shell scripts which perform some actions on set of servers, right? So servers IP addresses, let's say for example they are fixed, or IP can be dynamic, but host names are mostly fixed, right? So host name does not really change every time. So in that case, you can set up the host name variables as the read only variables, and whenever you want to read those variables, you can just print it or do echo or whatever, right? So you can use dollar in order to get the value of those read only variables, but there is no requirement to edit those variables. So that is why you create a read only variable. So that's a use case of read only. For example, if I modify this here, once the value is printed, and if I say where equals to test, okay, so it's printing me. After that, it says it's a read only variable. So line number 7, when it tries to manipulate the variable, it tries to add some values or change the value instead of that variable value. Read only variable does not support that. So you have to go to a different shell and then change the value. So what I'm trying to say is, as we saw that it's not letting me assign the value, but what I will do, I'll go to a different shell by pressing command bash. I am onto the different session, and then I can change the value, because that variable is no longer a read only variable, because this var1 is different than this var1, because this var1 was created in the previous session of our shell, but this var1 is the new session of our shell. So that's why they are different. Okay, they are not, they are local actually. So they are currently, if I try the same way, it will not work, because currently on my local shell session, this variable 1 is a read only variable. So that's why you cannot make any modifications to it. And if you want to unset the variable, you can use unset command, and then or you can not unset also. Read only variables cannot be unset, only the normal variables. Let's say if I create var1 jj, and if I print var2, okay, it will print it. You can use command unset. Okay, this will unset the value. So that's how you can unset the value. But read only variable, you cannot do anything actually. You cannot unset also, you cannot add values also, you cannot do any operation. So the only solution, possible solution would be either you have to go to a different session or relog into the shell and then do start from the scratch. Basically it can just be read once or read multiple times, but it cannot be overwritten, it cannot be changed. That's why the name itself is read only for those variables, right? So we will see the differences between the various variable types. So first examples what we have seen so far are the local variables, which means the variables which are locally available for the current session of the shell. Okay, now let's talk about environmental variable. So if you want to create a variable which is environmentally supported, those variables you can export and then use it to a different shell session also. For example, for that you have to use command export. So I am using variable h1 with trainer, let's say Himanshu, and okay, this is a read only. I will make var2. Okay, export var3 star agile. Okay, now these are the variables that I have exported. So if I want to see the value of these two, Himanshu, and var3 is it's star agile. What if I go to a different shell? Okay, then if I try to print the value, it will print the value for me, because this time I have not created the local variables. This time I created the variables which can be exported to a different shell also. So these are the environmental variables. So that is the difference between local variables or environmental variables. So you can export the variable once and then n number of times. So if I change the shell also here, and let's say it prints, okay, it does not print here. These are not shell based in the same session, but in the same environment it can be usable. But the global variable that we are going to come up next, right? So the global variable can be used from anywhere. Basically, you execute from this shell or whatever, you will be able to execute it. So these are all global variables. Var3 is not printing up here. What if I create one more session? Echo $var3. Okay, this is not being environmental variables. You cannot use like this also. Close terminal. All right. Okay, so now let's talk about shell variables, or the variables which are basically being used in any shell that you are using. So these are the shell variables, or global variables. You can think like, it can be used from any shell sessions, or it can be used from any other users also can use it. Anybody in this system tries to find the value of $shell, they will get the shell value, whatever the shell is assigned to them. If they are user, then depending on which cell that you have created from etc scale, or something settings that you have to change, but this will print the values of what it should supposed to be of shell. Then for example, like ps, that we have seen in our previous chapters, to print the value of ps1 ps2. So these are also shell variables. It's available on the shell. from any shell you want to print the value, it will go for it, and then you'll be able to print the value for you. So that's how the differentiation we see between local variable, then environmental variable, and the the shell variables or the global variables. So, and then there are some spatial variables which contain some spatial meaning when we talk about Linux systems. So for example, like there is a variable called $0. So this variable is being used to identify the shell script name, whatever the script that you are executing. So this is a spatial variable. So let's see, spatial variable. Okay, so this is a script. If you look at here, we are printing 3 lines. One line is we are printing script name, and then this variable is a spatial variable which basically prints the output of your script. Okay, whatever the script that you are currently running. So it will print the output for you. Similarly, $1 will print the first argument. Okay, and $hash will print the total number of arguments that you are passing to a script. So let's say if I execute my script spatial variable and I pass argument 1, argument 2, argument 3. Okay, let's say for example I'm passing 3 arguments to my script. So it will say the script name. What is the script name? This is the script name, spatial variable.sh. Okay, so this is script name will be printed as a script name. So this value, how did it come? It came by this dollar and then 0. So this basically nothing but prints the script name of which you are trying to execute. So this is a spatial variable, you can make a note of it. Second one we use to get the first argument of our script, which is $1. Okay, so you see the first argument of our script was argument 1. So this is how you're getting. Third one, the last one we used $hash, which means total number of arguments that you are passing in your scripts. It will print that value for you. So here in spatial variable.sh, it is passing 3 arguments for you. So argument 1, argument 2, and argument 3. That's why you are getting number of total argument is 3. Let's make some changes, and anything you just pass on, let's say 7, 8, some values I'm providing. So it is saying that first argument is 7 because it always prints the first argument for you. Which value? $1. So this always prints the first argument. Okay, then total number of argument are 8. If you count these values, 1, 2, 3, 4, these are 8 values. What if you want to print the second argument? So for that you can just say second argument and $2. So this will print the second argument. So second argument is number 8. Okay, so that's how you can use these spatial variables basically. Now let's see some other use cases of spatial variables. For example, we'll open it up. So for example, we see something like this, basically it's using the spatial variables and then it's printing it out. So the variable what you are seeing here, so this is the variable for, it defines the individual string. So if you are using this variable, so it takes the individual string and then it does for loop and then takes the argument for individual string that you would want to put it, and then it prints the value whatever you would want argument to be passed on from that loop. And this spatial variable is basically being used to as a single string. So argument as a single string it takes and then it prints the value from it. So I'll just show this use case so that you get the more clarity. So let's say if I pass 1, 2 and 3. So one spatial variable can provide the value like 1 and then 2 and then 3, and another one which takes in the single string will print the value 1, 2, 3 together. So see the difference here. If you use this, it will print value 1 by 1. So whatever the argument that you are providing, it will take first value and then it will take a new line character and then print the another value and last one. But using dollar star, it will take all the argument value in one liner. So that is a difference between using these special variables. Now let's review some other special variables. So this basically prints the exit status code. So let's say, for example, you executed a command, okay, and you need the output if the command was correct, perfectly fine executed or not. So if the command was failed, then you have to make some additional conditions where you have to make any changes in your code and do stuff. So how do you capture the exit status code of any command? So if it is executed successfully, the status code, let's say you want 0, or if it is not successfully executed, then you want status code as a 1. So this variable dollar question mark will basically print the value of last command that has been executed. If it is successful, then it's 0, otherwise it's 1. So what is this doing? It is basically trying to do ls on slash. Let's see if it is able to do ls slash. So currently I'm with star agile. Let me execute this. I am able to do ls slash. So if I execute my script variable 3, it will work because it will first print the value of ls and then it will say exit status code is 0, which means the last command that you have executed is successfully able to execute the on the Linux machine. Let's make some changes now, or instead of this, I want to read the home directory of parallel user, which Star Agile does not have access to. This is user Star Agile does not have access to the parallels users home directory. So now let's try to execute this. It says ls, when you execute ls, it says cannot execute open directories and publisher right, and you're getting status code which is not 0. So sometimes that's a issue, right? To identify any exit status code which is not 0, that means the command was not successfully executed. So that's the advantage of being capturing the status codes, and later then you can use, okay, stop my script as soon as the value of exit status is not 0. So in that case it will be helpful for any use case. You can just break the loop, or you can skip that parsing and then do further. So these are the advantages of being using spatial spatial variables in your Linux shell scripting. So let's say like you can have like multiple changes, and then you can have like you are just capturing that value, and then once the value is like, if let's say if I say if $1 question mark is not equals to or equals to 0, then print successful execution, something like that. You can have any sort of changes here. So let's say else execution failed. Okay, so it's not able to. Okay, there is syntax error, something is wrong here. It's not taking that value. There might be some syntax problem here, but the concept, what I'm trying to understand is that you can capture those exit status code, and then let's say if you can do like this. Let me just try, let's say variable or exit code dollar question mark. Okay, but this will be echo code. This will just print the value of, this will not say 0, or let's say ls, then okay, so ls/home parallels. Okay, this still printing 0 for you. It's not taking the real-time value, it's not updating because it's a scalar variable here. But yeah, I mean, what I'm trying to say is that you can based on your use cases, you can make a change saying that, okay, if this value is not 0, there might be some syntax problem, but yeah, once we have that corrected, so it can take that execution and prints the value, okay, it's a successful execution, otherwise it will be a failed execution. So we can make changes like that. So it's always good to capture the output like this, and then on top of it you can make any sort of executions after that. So that is what about the special variables that we have seen so far, where it can, some variables can capture, let's say $1 can capture the first argument, similar to $n can capture the last argument and stuff. Total number of arguments $hash it can provide you, or then we saw $0 and stuff, so to capture this script name itself. So there are variables like this logic, the local variables, scalar variables, then read-only variables which cannot be unset, also which cannot be having overwritten values if we try to provide some other values to it. Also there are some environmental variables you can provide in the environment using export commands, and then those variables can help you to use it environmentally. Then there are some shell variables or the global variables, for example pwd, echo $path. So these are the variables which you can basically try to use it in your Linux things. Also, let me try to show you how do you create your own command. For example, like this is kind of interesting, people might have questions about, I want to create my own command which does the processing, whatever. Let's say I want to create my own command ls, but I don't want to name it like ls, or let's say ls-al. So instead of that, I want to create my own command called Himanshu, and then if I say, what it does is it just do ls-al. Okay, I just save it. Let me set the permission, because every executable should have executable permission. Then you can just shift or you move this to any sort of shell variables in the, let's say, path, right? So you can just move or copy to, let's say you can copy to user sbin or user bin folder. Once you do that via sudo privileges, you can execute command Himanshu. So the Himanshu command will be created. So something like that, you can create your own command. It will be nothing but equivalent to what ls-al is doing. So this is how you can communicate to Linux machine, saying that the customization I want as per my own needs, so I can change the settings whatever I would want to change. So that's what the capability of Linux it provides in terms of using the shell scriptings and commands that you can manipulate in the paths. So yeah, that's about the variables and arguments that we have been seeing so far in the shell scriptings in Linux.
If you want to learn Linux and get certified from IBM, click on this link given below in the description. That's a wrap for this chapter. I'll meet you in the next episode of this Linux series.